Sixth grade math with Mr. Anderson.
All right, class. Today we will be comparing ratios, but with word problems. So that means you have to read very carefully, okay? And you have to write stuff down and label it, okay? Because if we write more stuff down, that's less we're trying to do in our head. So that's less to think about, okay? So it's very important that we do that. So I want you to do this problem with me. Jake is making bracelets to give to his sisters. Oh, what a nice brother that Jake is. He uses 4 rainbow charms and 8 white star charms for his younger sister's bracelet. So I'm going to put a Y. You can put a Y on your board for younger sister, so I know it's the younger. And the ratio is 4 rainbow charms. That's why I have an R there. For 8 white star charms. Okay? So that's a ratio, 4 to 8. Now, next part. He makes his older sister's bracelet, I'll put an O for older, a little bigger. Probably because she is a little bigger, you need a bigger bracelet. So, he uses 5 rainbow charms and 10 white star charms. So it's 5 rainbow to 10 white. Now here's the question. Does Jake use the same ratio of rainbow charms to white charms in both bracelets? So we're finding out, are those equal? Are those ratios the same? Okay. Well, there's 2 ways to solve, if you remember this. One way, put them both in simplest form. Okay. So 4 eighths. I can divide the top and bottom by 4. And get 1 rainbow for every 4 white star. Oops. I'm dividing by 4, excuse me. So it's 1 rainbow. There we go. For every 2 white star charms. Now, this one. 5/10, what's that in simplest form? Well, that's a half, right? Divide top and bottom by 5. So we have 1 rainbow for every 2 white. And as you can see, a half is a half. So, yes, it is equal. Now, there is another way, which a lot of people like. Okay, and that is the butterfly method to see if they're equal. So if I circle the diagonal here and multiply those 2 numbers, 4 times 10, that's 40. And I always put it on top. Okay? And then I do 8 times 5, and that's 40. And so that tells me that they're both the same ratio. So yes, they are equals. They're both 40. Okay? Let's try this one. Manny and his friend Vince go apple picking every October. This year, Manny, I'm going to put an N for Manny, you do that too, picked 4 pounds of red apples and 5 pounds of green apples. So that's, what ratio is that? That is 4 pounds, that's LB, right, for pounds, of red, I'll put an R for red, to 5 pounds of green. Okay? Now Vince, I'll put a V as Vince, picked 3 pounds of red apples and 6 pounds of green apples. So 6 pounds of green. Hopefully you've gotten this written down like I'm doing it. Now here's the question. Did Manny and Vince pick the same ratio of red apples to green apples? Yes or no? So we're finding out if these are equal. So how do we do this? Well, 4/5 in simplest form. 3/6 isn't. So what can we do? We can make this 1/2. As you can see, they're not equal. 4/5 isn't the same as 1/2. So it'd be no, right? They're not the same ratio. Butterfly method, 4 times 6 that's 24. 5 times 3, that's 15. And so they're not equal, are they? Okay? So that is a no, they're not equal. Does that make sense what we're doing? Okay? But it helps if you write it down, label it. I will have you try this one. Last night, Clara and her brother Stefan made personal pizzas for dinner. Clara put 4 pepperoni pieces and 6 ham pieces on her pizza. Ooh, I like ham, but I don't like it on my pizza. But anyway, that's just me. Now Stefan put 6 pepperoni pieces and 10 ham pieces on his pizza. Did Clara's and Stefan's pizza have the same ratio of pepperoni pieces to ham pieces? Well, you can pause it and figure it out, then push play when you have it. All right, so we have Clara. So I put a C for Clara. Did you do that? And it is 4 pepperoni for 6 ham pieces. And we're finding out if they're the same, so we're finding out if they're equal. And then Stefan did 6 pepperoni for every 10 ham. Now what did you do to solve? Did you put it in simplest form? Or did you do butterfly? I'll do butterfly. That's 40. 4 times 10 is 40, and 6 times 6 is 36. And so, no, it's not the same ratio, is it? Put it in simplest form, divide the top bottom by 2 on this side, and you get 2 pepperonis for every 3 ham. Now on this side, I divide by 2, and you get 3 pepperonis for every 5 ham. Okay, and they're not the same ratio. That's simplest form. Okay? Hopefully you got that. All right. And eventually, you'll get to a problem like this. Okay? So let's go through this one together. Monica made strawberry lemonade to serve at her birthday party. In a large pitcher, okay, so it's a large pitcher, put an L for large, she mixed 8 ounces of strawberry puree. Put an S. Now, strawberry puree, that's like when you get strawberries and you blend them all together, so it makes it puree. Okay? So 8 ounces of strawberry puree and 40 ounces of lemonade. Ooh, that sounds good. 40 ounces of lemonade. So it's a strawberry lemonade, isn't it? So let's see, where do we leave off? She had some strawberries left over. So she made another smaller batch. She mixed 5 ounces of strawberry puree. So 5 ounces of strawberry puree. And 20 ounces of lemonade. 20 ounces of lemonade in a small jug. So I'll put an S up here for small. Okay, large and small. Which container's strawberry lemonade had a stronger strawberry flavor? So which one had a stronger strawberry flavor? Okay. So here's how we got to think about this. If I put this in simplest form, 8/40. Okay, let me switch markers here. I'm going to put this in simplest form. I can divide by 8. And I can divide this by 8, can't I? It goes into both. So that means for every 1 ounce of strawberry puree, there was 5 ounces of lemonade. Okay? Now over here. I can divide top and bottom by 5. So that's 1 ounce of strawberry puree. Divide the bottom by 5, and I get 4 ounces of lemonade. Now, can you tell which one's going to have a stronger strawberry flavor? The large or the small? Okay. Well, think about it like this. You're putting 1 ounce of strawberry in each one. So if I put 1 ounce, where can I draw this? So let's say that's 1 ounce, like this, strawberry. And this one's the large, and this one's the small. This is after we put it in simplest form. So I put 1 ounce in each. Okay? And then for the large here, it has 5 ounces. So that's 1, 2, oops, supposed to be equal. 2, 3, 4, 5 of lemonade. This one has 1. Not pretty accurate here, am I? 2, 3, 4. Okay? So, which is going to have a stronger lemonade flavor? Sorry, a stronger strawberry flavor. Well, it's going to be the one with less lemonade, right? So this one has less lemonade. It's going to have a stronger strawberry flavor. While this one over here, the large one, this has 5 ounces of lemonade. This one only has 4, right? And so the strawberry is going to be more diluted in the large pitcher. Okay? If that kind of makes sense. Just like if you had a swimming pool and you dump salt in it, you're probably not going to taste that salt, are you? Now, let's say you use a much smaller glass, okay, with water, and you dump the same amount of salt, a bunch. We'll call the bunch is the same, okay? Yeah, you're not going to taste it in the pool. By the way, don't taste pool water, but you will taste it in that cup, right? Okay, so the smaller cup with less water is going to have the saltier flavor, okay? So on this one, it's going to be the small that has a strawberry flavor. Now, if that doesn't make sense, you can always do this. Butterfly method. 8 times 20 is 60. Sorry, 160. And 40 times 5, that's 200. 200 is the bigger one, and that's the small. And so the small is going to have the stronger flavor. So it'd be this one right here. Okay? A little bit of thinking there. Okay? Now, probably the easiest way is to do the butterfly method on these kind of problems. Okay? But I just kind of want you to see what it might kind of look like. So let's try this one. Emmett set up a bubble station for his little sister's birthday party. He filled a bubble machine. Would be for bubble machine. Let me see what's the other one called. Oh yeah, B for bubble machine. And a bottle for kids to blow their own bubbles. And so we have a bubble machine. And we have a bottle. Okay. In the bubble machine, Emmett mixed 12 ounces of dish soap and 24 ounces of water. So 12 ounces of soap, 24 ounces of water. If you haven't written this down yet, do that, please. Okay, you can push pause and push play. In the bottle, you mix 5 ounces of dish soap, so 5 ounces of soap, and 9 ounces of water. Okay, which container had the greater ratio of dish soap to water? Now, one way we could solve this is to find a common denominator and find equivalent fractions, but that looks pretty tough on this one. So we're going to do butterfly. Okay, so I recommend butterfly in these ones. So why don't you try butterfly and see what you get. 12 times 9. It's 18. 108. 5 times 24. That's 120. Okay? So the bottle is bigger, isn't it? It's greater. So the bottle has the greater ratio. That's how we figured it out. All right. On this one, there are no numbers. So you're going to have to maybe draw a picture with me here to help understand it. Okay? So let's do this one together. Okay, Meg visited her Aunt Clara for lunch. After they ate, Aunt Clara made tea. She put the same, that's important, amount of black tea and milk in both of their cups. But Meg decided to add some extra milk to hers. Which cup of tea was darker after she had finished adding milk? Okay, so what do we know? She put the same amount of black tea and milk in both of their cups. So we have Aunt Clara and we have Meg. And she put tea, the same amount in each. And then she put the same amount of milk in each. So it's the same ratio. Okay? And then here it says Meg decided to add some extra milk to hers. So Meg is adding extra milk. I'm putting a plus sign to say, just to show that there's more milk in her tea. So which cup of tea was darker after they had finished adding milk? So maybe sometimes it's helpful to draw a picture. So I'm going to draw a picture and we'll assume that these are the same size cups. Okay? And so I better label this as Aunt Clara's and this one's Meg. Okay, you put tea in both, right? And tea is usually black, right? Black tea. So Aunt Clara put some milk in each one. I'll show you a drop of milk there. Okay? But then Meg decided to add some extra milk. So what happens when you add extra white milk to the tea? Well, it gets lighter, right? Okay? So that means that Meg's is going to be a lighter color. Which then would mean if Aunt Clara has less milk in there, hers is going to be a darker color. Now do you see how we can figure this out? So who has a darker tea? Well, Aunt Clara's cup of tea was darker. So it would be that one. Okay? Does that make sense how we did that? Without any numbers. Okay, you have to kind of visualize what's going on. All right, we'll get to another one like this too. This one I want you to try on your own, but I'll still read it to you. Most of the cars at the Green Pine Auto Dealership sells are minivans and sedans. Sedan is like a car. In January, that sounds important. They sold 10 minivans and 20 sedans. In February, sounds important, the dealership ran some promotions and they sold 15 minivans and 25 sedans. During which month did the dealership sell a greater ratio of minivans to sedans? All right, set this up. And when you think you've got it, push play and check and listen and follow along to see if you did. All right, start with January. So underline 10 minivans to 20 sedans. And then February. In fact, I'm going to move this a little bit closer. Don't need those so far apart. They sold 15 minivans to 25 sedans. All right. And we're looking for which month is greater ratio of minivans to sedans. Probably butterfly method, right? Would just be the easiest. 25 times 10, that's not too bad. That's just 250. 20 times 15. That's a bad 50, isn't it? Let's make that a little neater for you. Okay, so 20 times 15 or 15 times 20, same thing, right? 5 times 0 is 0. 2 times 5 is 10. Down by 0. Cross that out. 1 times 0 is 0. 1 times 2 is 2. I add those two numbers and it's 300. Okay? And so now we can see that February is bigger. It's a greater ratio. So which answer is that? the dealership sold a greater ratio in February. It's this one. Okay? So those promotions that they ran in February must have worked. They sold more cars and minivans, a better ratio. Okay. All right, this one is another one without any words. And some of you that have made frosting with food coloring, you'll know. You'll understand this one a little better, maybe. Mabel and her twin sister, Molly. So we have Mabel. Mabel and Molly. Okay, write that down if you haven't. So Mabel and her twin sister, Molly, are making pink frosting to decorate cupcakes for their birthday party. They use the same amount of pink food coloring. Okay? So they both use pink food coloring, the same amount. That's important. But Mabel here, old Mabel, uses more white buttercream frosting than Molly. Okay? So they both use white frosting, except Mabel uses more. Whose frosting will be a darker shade of pink? Okay. Again, sometimes pictures help. So we have Mabel. And we have Molly. And Mabel has more frosting, so I'm going to draw a bigger bowl, because her bowl is going to be bigger. More frosting in it, right? It's full of frosting. Molly's will be smaller, smaller bowl. She's got her frosting. And they put the same amount of pink food coloring in. So let's just say 3 drops, just to make it simple. All right. So in goes those drops. In goes the drops. This one's hovering on the top. You get it though. You mix it up, right? You mix it up. You mix it up. Oh, now I can mix it up. No, I can't. Okay. So which one's going to be a darker shade? What do you think? Mabel or Molly? Think you got it? The darker shade is going to be Molly. Now why? Well, there's less white frosting compared to food coloring. So it's going to be a darker color. For Mabel's here, she's got more frosting and more frosting, and so the food coloring will get spread out more and won't be as dark. It'll be a lighter shade of pink. So Molly's will be that darker shade of pink. Does that make sense? I hope. Right? I wish I had some examples that I could actually show you right now, but I just don't have them in the classroom. Okay? Like real life examples, I could do this. All right. So that's your IXLs for today. You'll get a few of those problems where there's no numbers. You have to kind of think it through. The rest, probably butterfly method might be the easiest on a lot of them, but not all of them. Okay? All right. Good luck. If you have questions, let me know.